Good morning to everybody. Today we are starting with this lab that is concerning multitemporal analysis. And in this way, this topic is partially different from the others for what we have already seen in the previous labs. This topic is so particular that we are analyzing this multitemporal analysis with a particular labs, one of the last labs of the year. So, in order to approach this problem, we need a bunch of data, and these data are on your portal. I mean, in the Dropbox folder. And let's see where these data are. So we can open just with the icon open here. And I have this data here. The directory that I added in your Dropbox is called Multitemporal Analysis. You see here, and in this folder, we have three different subfolder. The first one is a single year, 2015. Then we have this folder that is called AOI, that stands for Area of Interest. And the third one is, you see, LC change, July, August. We will start with this first folder that is called 2015. And when we are opening this folder, you see we have 5 different acquisition date. So that means that in all these subfolders, we have a scene acquired by Landsat 8. So you see, we have the first one that was acquired the 1st of April, all in 2015. The second one, the 4th of June. The third one, the 22nd of July. The fourth one, the 7th of August here. And the last one, the 24th of September. All right. So let's start with the first one, the first subfolder that is the 1st of April in 2015, and you see we have different files, but what we need to open, of course, is the bigger data, that is the image. You see here that has this name. So that means that this name, eventually this file was created by myself. So I mean, this is not the original file you can get over the NASA sites where you can download the Landsat file, but it's something that I already prepared for you, and you will understand why. Here, the name means that this is a Landsat 8, the acquisition date, and then we have this SRLS that is something that is standing for the fact that, this data is already calibrated. All right. So that's why it's so big. You see, it's more than 1.5 gigabytes of data. All right. So let's open this file. All right. You see here we have this file as usual. Let's check which is the file we are opening. You see here is always the same kind of data we are used to approach. This is a scene of Landsat 8, you see, where we can here just have all our different data. All right, so that seems to be one single band. You see, one band, because we didn't use the metadata. So by option is visualizing only the first band. So in order to better understand what kind of data is this one, we can go to the data manager and, for example, just seeing the visible. I remind you that this is a Landsat 8. So you remember the Landsat 8. The Landsat 8 is composed by 7 different bands in the dataset that is recording reflectance, where the band 1 and the band 2 are two subbands in the blue of the visible. Band 3 is the green. Band 4 is the red, band 5 is the near infrared, and band 6 and 7 are mid infrared. So if I want to see a visible, I have to select, and I've exploded here the band selection. I have to associate to the RGB channel band 3, I'm sorry, 4, 3, and 2 in this order. Okay? If I'm loading this data, you see I have the visible. All right? So here we have always the same image, but it's acquired in 2015 and it's a Landsat 8. So you see down here we have, you see the Genoa Harbor, Genoa port, and then in this position, more or less, you see here, and now it's it's regenerating the image. This is Torino, all right? Okay, so this is the image. Of course, we have also the possibility to display a false color one. So I'm exploding the false color in RGB is 543. Let's load this data here. And you see, this is the false color. So you see that as usual, this image is acquired in April. So pay attention. You see, we have very few clouds. The image is more or less all vegetated, and we have here in the southern part of the Alps and here part of something that could be snow. You know, it's in April, so we have at that time in 2015 we had still snow. All right, so this is the situation. All right, what we can do with this image? With this image, our aim in this, my aim in this lab is just to show you how we can, for example, analyze a multitemporal issue or problem or analysis, a multitemporal analysis in order to highlight some vegetation features. Because you see here we have more or less vegetation, many vegetation here. And so we want to check in particular part of this image the facts that we have changing in the vegetation, because what we want to do right now is just to highlight the vegetation cycle of an entire year, an active phenological season that is starting from April and is going to till September. So we want to see how the vegetation is growing in that period of 2015. All right, so let's have a look to this data. So let's right click with the mouse in the layer manager and have a look to the quick stats. So you know the quick stats is quite, in this case, the data is very huge, big, and so I mean this operation will take some times because I mean it's quite big. Anyway, consider that we will not, process all the image from now on. So now we are just having a look to this data of acquired in April, and we will not do the same things for all the other data because you see it takes some time. So this is just for the first time in order to have a look to the data. And after this operation, whatever we do, we will perform this operation over a spatial subset. Otherwise, you see, these data are really too big in order to be processed. So I mean, you see, we need to wait a while in order to have the results only of these things related to the data manager. So let's wait till the process is concluded. So you see, it's in the way to finish. We will see now the windows that is representing our data. Okay, here it is. These are the data. So you see, as I mentioned, we have 7 different bands. This is the diagram. Here we have not really a wavelengths because we are not using the metadata, but we have the number of bands, so band 1, 2, 3, and so on. And here we have the data, the calibrated data. And you see, this calibrated data, you see, it's related to the fact that they are ranging from 0 to a little bit more than 1. They are calibrated with a particular way, but you see that the mean value that is calculated is negative. Why is negative? Just because, I mean, the background of the image has been set to -1, all right, minus 0.9999 in order just to perform the dart subtraction. So in this case, these data are also dart subtracted. So I mean, for example, if we are just having a look to the histogram, of the band, of the band 5, that is the near infrared, you see this is the distribution. So you see here we have all the things that are not vegetation, and in this peak we have all the vegetation. So for example, if we are having a look to the band 1, this is the band 1, that is the blue band, and you see all the data are compressed in this part here. While of course, in this kind of image, in the infrared, in the near infrared, we have a bimodal distribution. This is due to the fact that we have all this water here and all this vegetated place here. So I mean, the water is a very poor reflectors in the near infrared, while the vegetation, of course, is reflecting much more than the water in the near infrared. All right, so we had a look to this data, and now we are done and we can close this operation. All right, so now we are here, and now what we want to do. In order to analyze the vegetation, you remember that during a particular labs, we took into account the possibility to build spectral indexes, all right? And to build spectral indexes, you remember, we went to this toolbox menu, band algebra, and then we went to these spectral indexes, all right? So double clicking on here, we can select the band and then just have all the possible set of indexes that are available. Unfortunately, here you see when I try to select this file here, you see the answer is that the input raster must have valid wavelengths metadata. We didn't open that as a metadata. We can add later on all this information, but I mean, we don't want to waste time because I mean, we need to edit the metadata of this file that we have, but we need to add all the wavelengths. So I mean, we are not using this part of menu because taking into account that we want to process some spectral indexes concerning vegetation, we can try to understand if there are something in the other menus. And for example, here you see we have this menu that is called spectral. And in this spectral, you see we have this folder and these operations that are related to vegetation. Let's explore this vegetation. And you see we have here, I'm enlarging that, we are here, you see agricultural stress vegetation analysis, fire fuel, forest health vegetation analysis, and then we have, for example, NDVI. And you remember that the NDVI stands for Normalized Difference Vegetation Index. That is an index that is ranging between -1 to +1, and this is simply the ratio of the difference between the reflectance recorded in the infrared minus the reflectance recorded in the red, divided by the sum of these two reflectance, infrared plus red. So very simple. That means that this normalized index is ranging between -1 to +1. When the results is close to 0, that means that in the numerator, the values that are registered in every single cell for the near infrared and the red band are quite the same. So it means that with zero value in the NDVI, you will have something that is reflecting more or less in the same way in these two spectral bands. When you have values that are less than zero, that means they are negative, is prevailing the reflectance in the red band. All right. While when you have values that are more than zero, in particular more than zero point 0.4, zero point 0.5, that means that for sure this is vegetation, where the reflectance in band 4 is bigger than the reflectance in the red, where in the vegetation we have an absorption peak. You remember? I'm sorry. So let's see if we can perform this operation from here without passing through a bandmat. So double click on the NDVI and you see we have this image and we can click on this image. All right, it seems to work right now. But as I mentioned before, we are not using all the image because otherwise, I mean, the calculation and the data we are creating is too big, but we are creating a spatial subset. So we are clicking here, and in order, and now we are learning something more, to use all together the same spatial subset, you have in the data, in the folder that is called AOI, Area of Interest, this EVF file. EVF file stands for MV vector file. So click on this button here, go to the multitemporal analysis, open this folder, AOI, okay, AOI, and you see we have AOI 4 underscore dot EVF, that is an MV a vector file, is simply a frame, a rectangle that will define our area of interest. Click on that, open it, and you see now it's here. It's in this new Windows. Simply select that and click OK. All right. And you see when you're clicking OK, you see that something is changed and the image we will use will be a sample, that means a column, more than 2000 and 2621 lines. That will be the frame. If we want to see this frame, it's enough to click on image. You see, the frame we will use will be this one. Out of all this image, we are only using this small part of the image. All right, so we are not creating too many data. All right, so click OK and OK here. So we define, you see here, a subset. Then press OK. All right. And so you see, this is the NDVI windows, the calculation parameters. You see that the software understands that this is a Landsat, but unfortunately, it's understanding that this is a Landsat 7 data set, but this is not a Landsat 7, this is a Landsat 8, and this suggesting to us that the red band is the number 3 and the near infrared bands is the number 4. This is not true because you remember, we cannot open that things here, but we will, I'm sorry, I'm just cancel these things here because I need to have the data manager. You remember the red band is the number 4 because 1 and 2 are two blue band, 3 is the green, 4 is the red, 5 is the infrared, 6 and 7 are mid-infrared, all right? And so, considering that for the NDVI we are using the near infrared and the red, again here, NDVI, we are doing the same thing as before, spatial subset, raw EVF. If you have already opened these things here, you will find that here. So we are selecting that. We are just checking in the image that it is okay, all right. We are pressing OK, OK again. And so you see for the red band, this is not the band 3, but is the band 4. And for the near infrared is band 5. All right. Then I'm choosing a new position. And so I'm going here. Maybe I'm just, let me check if I can have a new folder. And this new folder, I call that multi-temporal analysis. All right. Okay, so I'm going to the multi-temporal analysis, and I'm calling that, for example, I don't know, NDVI uh, of April. Okay, it's no, that's, I mean, I'm not interested in the year because all these data are coming from 2015. So I'm creating this NDVI. All right, so I'm opening the file. It's calculating in floating point, of course, because I mean it needs to store the results in a range between minus 1 and plus 1, so in decimal, in a real value, and so we can process this data. All right, it's quite quick because I mean the processing is always it's only this very little part. So I mean if we are going to this image, you see here, this is the NDVI. So you see whatever is very dark is characterized by a lower NDVI, right? So for example, if we are going here with the cursor location value and we are going in a very dark place here, you see that, I mean, the NDVI is 0.14. If we are going to a very bright area here, for example, you see the data, the NDVI is 0.86, 87, I'm sorry. Here in this very dark area, you see that the data is 0.11, while if we are going, for example, to the river here, you see the river has a very low data, minus 0.69. Why the river has a very low data? Because you know, in the near infrared is a very, the water is a very good absorber of energy, and so that means that the NDVI will get a negative value, of course. And you see that in this case, whatever is very bright is for sure vegetation. Whatever is not so bright, that means that is not vegetation. So for example, here is Torino, you see, this is the urban center of Torino, this is the Po River, and all these rivers here, you see, are very dark. And there are also other darker area. You see another river downstreaming from here to the Po River. And so you see that, I mean, there are parts that are very dark, comprising this part here that is getting very dark in comparison with the other. And you see also here river from upstream that are coming from upstream. All right. Okay. Let's close that. And for example, for this file here, we can center that. Of course, we can also have a density slicing in order to better understand what is contained here. But before doing that, let's go to the NDVI, right click here in the layer manager, and let's see the quick stats. I mean, the quick stats is very quick because I mean the data is smaller than before, and you see that all the data are in some way in this range. You see, we have also a data that is minus 80, but this is only a calculation problem. In reality, these data are all comprised between -1 and +1. All right. And you see that, for example, if you are going to the histogram of the one single bands, you see that most data, all the data are comprised in this very small range. You see here from -1 to +1. All right. So if we are going here now to have a density slicing, right clicking here. So new raster color slice, you remember, we can use this NDVI image, and we can produce all these ranges. And you see all these ranges are of course, in this range, the image is all red because you see it's comprising all these different values. So I'm closing that. I'm adding these new things here. And for example, we can go from a negative value and for example, to put in red from minus 50 to 0, for example, and just to see what we have here. And you see these are the areas that are in this range, and you see that we have all these water here of the river. You see that all the more or less all the rivers are red, while for example we can have another range, for example in green, where we have from 0 0, let's add just a 1, and for example to 0.2, just to check what we have here. And you see here, in this small range, I'm coloring all the urban areas and all this area that is very dark, and all the other, the other, uh, the other rivers. And if we are adding another one, for example, this blue one, and we are ranging between zero point 0.2 to the maximum value, all right, here, you see, I have all the other things. So you see, all the vegetation is in this range of values. All right. So you see that it's all comprising that values. All right. Let's close it. And we can also close this raster color slice, just right clicking with the mouse here and just click remove on that. We don't need it. And we have this NDVI in April. All right, so now we are doing the same things for the other 4 different dates. Let's continue then with the other data. So let's go to here to open the new data sets. We are going to the 2015 folder. And here you see the second date is the 4th of June. So I'm opening this file, this one here, the bigger one. These are the HDR, that is the header file that is describing the characteristics of this file. This is an MV format, so don't panic. It's a format that MV is able to understand and to read. So we are selecting this file here, and we are opening that. All right. So here is the file. You see, you remember it's only one single band. In order to check if everything is okay, we can just go here. You see, here is the June bands. Let's have a selection, for example, 5, 4, 3, a false color in order to check that the data is okay. And let's load the data. And you see that this data, it's okay. You see here, we have a false color image. You see here with, in this case, with the false color. All right. I mean, we have some issues related to the fact that the data is quite big. This is the June image. So also for in this case, we are proceeding with the NDVI. So we are just go to the toolbox here. You see that now is working. You see here in this lower right part is building the pyramid. What does it mean building the pyramid? Is the fact that the software is building the different views in the different scales. So when we are zooming in and out, the visualization will be more quick than as we have seen right now. So we can anyway just double click on the NDVI. Is building the pyramid, but we can go on. So you see, this is the 4th of June. We are selecting this file, all right? And we are going to the spatial subset. You see, is adding all what was missing. You see that all the part now is reddish, all right? So we are going to the spatial subset here, and as before, we are going to raw EVF because we need to have always the same dimension and the same area for every single date. So we are just selecting the already opened MV vector file. We are clicking OK, just to click over image in order to check that it's in the same position. You see it is. And now we are going on. So I mean, let's press OK in the different menus. And now we are, and remember to do that, we are just changing the numbers of the two bands. The red is the number 4, the near infrared is the number 5. We are choosing the file. We are going here in multitemporal analysis. And for example, now I'm calling that NDVI June, right? And I'm opening that and I'm saving that, all right? Okay, and this is the NDVI for June. So you see that you see something different. We have these two darker areas. Here is Torino. This is a very dark area. And here you see we have a very bright tones. I mean, that means that the vegetation is growing in June here in this latitude. And so the NDVI is bigger because we have more reflectance in the near infrared and much absorption in the red band. So you see here now, if we are taking into account, let me check, the NDVI in April, okay, this is the NDVI in April, you see, and this is the NDVI in June. You see that is changing. Everything is brighter, you see, because the vegetation is growing. Here it is, okay? All right, so let's go on with the other one. So let's open, let's go to the third dates of acquisition, that is this one, you see, the 22nd of July. So let's open that. We are opening the new image. All right. You see, it's creating the raster pyramid. Let's have to check if everything is okay. Bottom of the list, you see, we have the July. We are exploding the band selection. We are just visualizing a false color 5, 4, 3, and we are loading this data. All right. In the meantime, you see it's building the raster. So, I mean, it's taking time in order to visualize everything. All right. So you see here that is reddish, this image. All right. Let's go with the NDVI. Okay. Double click on the NDVI. We are using the July image, spatial subset, raw EVF, select this file, press OK. Let's see, pressing on this button image, if everything is okay. Yes, it's here. Okay. And then we can press OK here and OK here. All right. And we are going through the NDVI for July, changing here in 4 and for the infrared in 5. And then we are choosing the new results that will be as before the NDVI now in July. All right, we are opening that and we are saving that. In the meantime, you see the software is still building the pyramid. You see here where I have the mouse, but don't panic. I mean, we don't need that. All right, now I mean it's slowing down all the procedure. This pyramid, you see. All right, we have a bunch of data, and I mean these are this is the NDVI image. Let me see. This is the July one. This is the June. I'm sorry, I'm just taking out these things here. Okay, this is the July and this is the June one. And you see that it's changing. You see that here now is not more black, but in July, I'm sorry, in July, you see it's becoming very bright. All right. Okay, let's go on. Let's go to with the August image. So let's open it. Let's go to August, the 7th of August. Let's open the file here, right? This is the file. Okay, now we'll build the pyramid, data manager. Let's again do the same things. Bottom of the list, 7th of August. In fourth column, we are visualizing band 5, 4, and 3. Okay, and we are loading the data. And you see, this is the data in 2015 acquired in August. All right, it's here. Let's go with the NDVI again. So we are using now this August image, spatial subset as before, raw EVF, select, okay. Let's see the image. It's here again, okay, okay, and then okay. Let's change the name of the bands, 4 and 5, and let's choose the new name of the file. So we have NDVI July, and now we will have NDVI August. All right, let's open it and let's save it. All right, this is the NDVI in August. So let me close these two things here. So if we are comparing August with July, you see, it's more or less the same. It's only one single month of difference, but you see that the image is becoming more different than before. I mean, it's not very changed, the NDVI, but it is different. Similar in August in comparison with July. And for example, in August, you see, if I comparing with June, you see that is very different, especially in this area here. All right. So let's open the last one. The last one will be the image of September. So let's go to the 24th of September here. Let's open the file here. Okay. Now it's opening the September file acquisition. All right. Now we are going again in the data manager, bottom of the list. This is September. Let's have the color composite 543 in fourth color. Let's load the data. You see, this is the data. It seems always also here to be different from before. Let's perform the NDVI calculation over this image, 24th of September, spatial subset, raw EVF, select the file, okay. Let's see if the image is okay. Okay, it's always in the same position, all right, okay. And then let's launch changing the number of the bands, 4 and 5 here, all right. And let's choose the new name that will be NDVI, and this is September. Okay, let's open it and let's process this data. Okay, it's finished. And you see, if I'm closing these two things here and I'm comparing the September NDVI with the August one, so I'm closing the September, you see that in September, all this area is becoming dark again. You see? That is dark, and also this area here is becoming dark, you see. So I mean, it's changing a lot. All right, so I mean, now we have our 5 different NDVIs. All right, and so for example, we can just stack together all these NDVI in the same file, because I mean it's better to have all these calculation, all the different 5 NDVIs in the same file and not in 5 different files. In order to do that, we are learning another things, because you can group different images like this one in the same file using this option. So if you are going here and you are just writing here, you see here in the toolbox, if you are just clicking layer, okay, you see that here is available now the option that is called layer stacking. What does it mean, layer stacking? that we are taking different layers and stack all together in the same file. All right, let's double click on this layer stacking over the toolbox. And you see that in these windows, you have two different parts. The right one is related to the reference system, to the cartographic reference system. That means that the layer stacking is working only with georeference data. All right, it's not working with not georeference data. You have another way to stack all together, but not with this particular option that is called layer stacking. So, I mean, this is the reference system. As you see, it's set over an American datum, but we are not taking into consideration these things. And now we need to group the different files here. How we can group? Of course, these files should be in the data manager, so should be already opened in Envy, and we can simply click here in import file. Okay, and you see in import file we have all what is available in the data manager. So just keeping press the control button over the keyboard, we are selecting the NDVI of September, August, July, June, and April. These 5 different files that, I mean, you see they have all the same dimensions. All right? Spatial subset, of course, the full scene, because also here we can subset data, but it's already subsetted. So, I mean, we don't need to do that anymore. And we are clicking OK. All right. So here we have, you see the different data, and unfortunately, they are put in the reverse order, starting with September, that is the last processing, and finishing with April. So in this case, for the layer stacking, it's very important to define a right way of grouping these different data. And so what I'm suggesting is just to group that, starting with the older one, the April one, at the end having the September. Otherwise, I mean, if you don't have any of these order, I mean, it's very difficult, as you will see later on, to understand the results. So in order to do that, is simply, and you see also here, I'm sorry, before that, you see that now the reference system is changed because the reference system of the image has been read, and it's here. So UTM, VGS 84, and the zone 32 north, and the resolution is 30 meters, is okay. But then back to what I mentioned before, we need to reorder these files. So just click here on this button, reorder files, and you see this is the list, and this is working with drag and drop. So dragging April, I taking it at the beginning, okay? Then I have June in the second position, then July in the third, then August in the fourth, and September in the fifth position. Do the same things, because when we later on we will discuss the results, we are taking into consideration that this is the right order from April through June, July, August, ending with September. All right? Okay. Then output file range inclusive, range encompasses all the files, all right, because you can also having file that partially overlap, but this is not the case. So let's the output, the results in the multispectral analysis, let's call that NDVI 2015, all right, the complete series. Okay, let's open it and let's save these different files. All right, now you see we have in the data manager, you see at the bottom of the list, we have this new file that is NDVI 2015 with all the 5 different NDVI we calculated over the 5 different months. This is the first case in which in the same file we don't have different spectral bands, but we have images, same images, but with a different temporal reference. And that's why it's different from before. Before, till now, we always use this kind of files. In a single file, different different spectral bands acquired in the same data. Now we have a multi-temporal file. We have the same kind of data, all NDVI, but acquired in different times. All right? So from here, we will starting to discuss the possible result. And now let's check what we can do with this different file. So before continuing, we have a bunch of data here. So I mean, right now it's better just to close everything and let's open only the very last file. So I mean, we can do that. We can go to the main menu file, we can close all files, all right? So otherwise we have too many data, and we are opening again from here, from the icon, simply the data that I put in the output directory, the multitemporal analysis. I'm only opening this NDVI 2015. So I have only this data here, all right? So this is one of the single NDVI. What we can do right now? So we can open the data manager. So you see here, I'm enlarging these windows in order to see all the full name of the data. And so now we can perform we can build over the three RGB channels a color image using this multi-temporal NDVI. I'm sorry. How we can do these things here? We can do, for example, starting with the first three data. For example, we can associate to the RGB channel the April, June, I'm sorry, this is an error. I'm associating to the green channel June and to the blue channel July. So pay attention because now it's very important what we did in the very first labs concerning colors management, because I mean here colors are very, very important, and now you will understand why. But consider that in this color image, in the red layer, I had April, all NDVI of course, April to the red, uh, June to the green, and July to the blue. All right. And now, for example, I can load in a new view the data. All right. Here it is. You see, let's, for example, link the two views. All right. So we are linking all. All right. So I mean, we can zooming out the image. All right. Now I'm panning it, and you see we have our image. These are the two images. This is one of the single bands. I don't remember what kind of this is the layer of April. All right. On the left side you have April, and here I have the first synthesis. All right. So let's consider these things here. Okay. The color image. This is very different from the spectral color image we created till now. So I mean colors, there was something that is related to the reflectance or to the emissivity of the different surfaces. Here is something different. So in a multitemporal color composite like this one, we have two evidence that are very clear. So whatever as a result of a multi-temporal color image, where to the three different channels, red, green, and blue, we associated a different image in a different acquisition or processing time, what is very clear, and this is the very first factor, is that whatever is in gray tones, so that means whatever that is ranging from black to white in all the possible gray tones, means that all the cells that are in gray tones represents surfaces that have not been changed during that time. So I mean, for example, you see here, let's go to Torino. You see here, Torino, the urban part of Torino didn't change over time. And that time is ranging between April to June and July. So you see that nothing changed in Torino. It's always very dark. Why it's very dark? Because the NDVI is very low in Torino. You know, it's very similar to zero as value. But in these three times, didn't change. While, for example, if we are going to other part of the image, for example, here in the river, you see that in the river is very black because the Indian DVI is a very low value, and these values remain stable over time. And you see that all these very dark spot here are urban centers, so are cities. You see here. So in this image, in this multitemporal color image, whatever is black, it's urban areas or rivers, all right? Which is the second evidence? The second evidence is that whatever is colored in this image means that something changed, all right? Because if you have any color, means that the situation in the three acquisition time of the NDVI, for example, in this case, but could also be the same band for the 5 different acquisition date. For example, we can also do this analysis using the near infrared band for the 5 different acquisition date, but it's quite limiting in comparison with the NDVI. But anyway, whatever is colored means that something changed in one or more than the acquisition date. Okay? So here is very important to understand principle and the complementary colors. For example, in all this area here, you see here, this one, that is bluish, that means that is prevailing the NDVI that is calculated over the date that is associated to the blue channel, while in the other two channels is remaining stable and very low. So that means that in this bluish area, remember the association in RGB that is April, June, and July. If this is blue, that means that in this area, the NDVI in July is higher than in April and June, and in April and June is very low. All right? So that means that in this area, the NDVI is bigger in July than in the other two dates. All right? What other colors we have here? You see that all this area here, it's a sort of whitish, all right? That is going and passing to a sort of cyan colors, all right? If it's whitish, that means that the NDVI is high for the 3 different acquisition, and this is always the same. So that means that when we have colors in multitemporal images, means that something changed. If we have, like in this case, whitish area, that means that the NDVI is very high, so it's vegetation for sure, and this vegetation didn't change from April to July. While in all the other colors, you see here, for example, we have a massive amount of cyan colors. What is the cyan? You remember? The cyan is the complementary color of red. So where you have cyan here, in this area here, that means that the NDVI in associated to the red band. So the April one was very low and was increasing in June and July. And in June and July, it's almost the same. So that means that again, you see how it's appearing, the texture and the shape of these things. These are crops, all right? In April, there were no vegetation, so the NDVI was very low because here the phenological cycle of the crops is starting with the beginning of the spring season. And of course, starting with May and June, the vegetation, these crops, are increasing and are vegetating. And in September, usually, here at this latitude, they are harvesting. Okay, so we are expecting that maybe in September we don't have anything here because there's no more vegetation because everything was harvested. All right, and you see that here we have a bunch of other different complementary colors. This is the yellow. What does it mean, yellow? Yellow is the complementary color of blue. So that means that all the yellow fields here have a very high NDVI in April and June, and they have a very low NDVI in July. All right. And here, you see, we have a very many crops that are magenta. Magenta is the complementary of green. So that means that the NDVI was very high in April and July, and was very low in June. What kind of crops we have in this in this area that is south of Torino? Usually we have vegetables, and these vegetables have very different cycles. So there are some things that is ready to be harvested in April, May, while there are other things that are being harvested in June and other in July, August, and September. So you see that all these crops here are very colored because they are representing the very different cultivation. And in particular, here they are cultivating vegetables. While here, in all the parts that is very whitish, and you see that here we have the shapes that are not really straight, these are forests. And this forest is characterized to have, of course, its vegetation. And of course, in April, we already have the leaves of the trees. And so they're in an active vegetation cycle. And so, this is whitish because, it remains stable. All right? While here, you see, if it's bluish, that is different from all these things here that you see have all the complementary colors, that means that is a particular cultivation. Because you see, if it's bluish in April and June, we don't have anything. All right, and you see, this is the NDVI in April. You see, it's very dark. It's very similar to water. What kind of crops are these one? You see, they are very regular, very straight, very rectangle shapes. This is a very famous part of the Piedmont region that is in that position. This is only a very small part because in Italy, this is the area where they are growing rice. Okay, so rice, you see, all the areas, these crops are flooded since June. So what you can get from here is an NDVI very low till June because there's water. And starting with July, the plants are coming out from the water. And so starting from July, you are seeing the vegetation growing above the surface of the water, of this very thin layer of water, because these crops are flooded. In August, we will see the same things, while in September, they are harvesting. And so I think in September, we will have again a drop of the NDVI because there's no vegetation anymore. They are taking out the water, the flooded water, and you have only bare soil without any kind of vegetation because the rice was harvested. So you see here we have a very different vegetation, a very different cultivation. And what we can also observe, we can also observe a very interesting things. If we are going here in Torino, you see that, all the urban area is very dark, while here you see we have full of colors here. What is this area? These areas you see here are part of the city, and you see also here, this is the Stupinigi Castle. You see that are very colored, and that means that are urban parks, all right, with different vegetation that you see we have many different colors. And these colors also in this part here, north of Torino, this is another urban park where the vegetation have a very different phenological cycles. So you can see that in blue, in yellow, in magenta, in orange, in reddish, and whatever. So this vegetation is have a very different vegetation cycles you see here. But what is very interesting here is that you see these are the roads of the city, all right? The main roads, of course. And you see that it's very strange because they are cyan. Why they are cyan? Roads are not changing. We have the asphalt, and the asphalt is the same in April and in till to July. What is changing? Let's say that if they are cyan, that means that you remember cyan is the complementary color of red. So that means that along these roads, we have a quite high NDVI in April and June, and is dropping down in July. What are these things here? These things here are trees that are on the side of this very large boulevard. And you see here, this is not the asphalt that is changing the NDVI, of course, but they are the trees that are on the side of these very large roads. And you see here that they are all cyan. That means that, these trees that are on the side of the roads are starting the vegetation cycle in April, then going to June. In July, it's dropping down because it's really hot, and so they are. I'm sorry, cyan is red, so in April is not active, and is increasing in June and July. I'm sorry, this is not yellow. So in April we don't have any leaves, and when they are starting the vegetation cycle, then in June and July, we see that cyan, because they are the trees along this very large boulevard of the city. So you see that using this multitemporal analysis, just taking into consideration the different colors, we can say many things. There are also some outliers here. You see here that we have over the hill east of Torino, we have this magenta, let's say, area. These are outliers. These are clouds that were one over one particular acquisition. Which one? If it's it's magenta, that means that is something that is associated to the green channel, so something that happened in June. All right. Okay, this is the first one. Let's activate this first view where we have the April one. Let's open again the data manager, and now we are using for the synthesis another color image. So we are taking out April, and we are starting to the red channel with June, then to July to the green, and then August to the blue. And we are putting these things here in these windows here. All right, and closing that. You see that if we are zooming out here and we are moving out from here, we have this image, and you see that it's different, of course, because now let's open that things here. This is the rice fields that were blue, because I mean the NDVI was high in July to the blue channel and not in June and April to the green and blue and red channel. Now it's becoming cyan. Cyan is the complementary color, you remember, of red. So that means that if this association is June, July, August, that means that the phenological cycle of rice, I mean, the plants are below, are over the surface of the water, and so they are reflecting much in the near infrared in July and August, and not in June. You see that here, all this forest part is very whitish, while here was a sort of cyan, because again, in cyan, that means that in April, the phenological cycle of this forest was very low. Now they are very whitish, while here, there's something that is, here you see, everything is cyan here, again. So the NDVI is very high in July and June, and not in July, I'm sorry, in August and not in June. Torino is always very dark, like the river, of course, while here we have parts that are becoming reddish. You see here that are part reddish, and this reddish part, of course, they are associated to the NDVI of June. So that means that in this reddish area, we'll add a higher NDVI in June that in July and August. So that means that our crops, you see, they are very regular. And so that means that, at the end of June, maybe they have been harvested. All right, that's why they are red. And let's see what is happening in Torino with our boulevard. And you see that now the boulevard from cyan, they change into white. Why white? Because I mean, June, July and August, the trees on the side of this boulevard were in active phenological cycle, so a very high NDVI. While all the parks there, you see that are changing the colors, because I mean there's another association, all right? While the water, you see the Po River here, is always very dark, of course. Whatever is whitish here seems to be, of course, and was cyan here. There are of course trees, forest, all right. While urban is always very black, all right. So let's go to the data manager and let's use the last association. And the last association, we have another shift and we are associating to the red channel July, to the green channel August, and to the blue channel September. And we load that in a new view. All right. Here is the new view. Let's link all together. So link all. Okay. Now we are here. Let's close everything. Let's go to our rice area. You see, this is the first, starting from June, right of the screen, left of the screen starting with July. I'm sorry, with June. We are starting with the blue, with the right screen. I'm sorry, I'm confusing the month. We are starting from April here, then from June, and then from July. This last one is July, August, September. Why is yellow? Yellow is the complementary color of blue. So that means that the two NDVIs that are associated to the red and green bands are very high, while the NDVI that is associated to the blue band is low. This is rice. So as I mentioned before, in September, they are harvesting and they are taking out the water from the flooded crops. So here you have bare soils. So you see, this is anti-clockwise, the different association. This is the situation that is show you the blue area of rice, because it's starting, the plants are starting to getting out from the water in July. Then in July and August, they are very active. And then here they are yellow, complementary of blue, because in September they are harvested. All right? Then you see, again, this area here. This is, you see, we are passing from cyan to whitish and still whitish area. I mean, these are forests. In September, they are still active. What about Torino City? Okay, boulevard with trees. We are passing from cyan to white and still white, because in September we have still leaves, and we need to wait end of September, beginning of October to have to see the leaves falling. All right. While river, you see, for example, here is always very black, and you see that all these areas you see from blue to cyan to yellow, this is again something that could be a rice, because I mean it's the same variation. And if we are going, I'm sorry, south of Torino, you see that we are passing from very colored areas. That means they are very different species, very different crops. Then we are passing to this cyan dominant color, and then we are passing to yellow colors. So consider that in general, I mean, in this part of the world, at this latitude, we have only one single cultural cycle that is starting from April and is ending in September. So again, here we have many corn for feeding animals, crops, and this is the cycle. Again, from April to September. In September, they are harvesting corn, all right? And you see, it's similar to rice in this representation. You see that we have here, this area that is very similar to rice. But when we are taking, and also here is very similar, because we are taking July and August. But when we are taking April, you see that it is very different. This is bluish. All right. So this is how we can analyze colors in multitemporal image. Now, in the last part of these labs, we are trying to characterize the phenological cycle of different surfaces, different vegetation surfaces we have here, and also to characterize, for example, elements like water or urban that is not changing. All right, so how we can now analyze, for example, the phenological cycle of rice with what could be corn and what, for example, could be the forest. So in order to do that, we can do something that is quite simple. For example, if we are going to this image here, maybe I'm just, you see, I'm enlarging, I'm zooming in, and for example, you see here there are very, very straight crops, and they are flooded. So I mean, you have here a sort of basin that is containing the water. What we can do here, for example, we can extract region of interest, all right? And having all the different NDVI in the same file, where when I'm extracting a region of interest, of course, that will be applied to all the 5 different NDVI. So how can I extract a spectral signature? I'm sorry, what is something that is not really spectral signature, but we will see. You see here I have a very nice yellow crops that I'm thinking that could be rice. So I can just activate the region of interest tool, all right? This one, okay? So you see here, I'm ready for using that. You see that the mouse transformed that in a cross here, the mouse, the pointer, in order to draw the polygon. But we need to define a new ROI. So the first ROI will be something that I'm calling that rice, all right? And maybe I put in that in let's say whitish, for example, all right? So staying away from the border, I'm taking here a very small polygons of what I'm consider rice, okay? And I'm completing the polygon, all right? Then zooming out, all right? Now I can, for example, move from here and passing, for example, here to what I consider to be, for example, forest, for example, a very whitish area here that you see cyan here and also whitish here. So new ROI, for example, I can call that forest, okay? And I'm putting that in green color, in dark green, this one, okay? And then just drawing a polygon here in this very whitish area, and I'm completing this polygon, all right? Then I'm zooming out, and I'm trying to pass to another polygon here, southern part of Torino. Let's check if we have something that could be highlighted here. So you see, there are very, very regular crops here. For example, this one is very yellowish, all right? I presume that could be corn. So I mean, new ROI, and I call that ROI corn, all right? And I'm putting as color a very bright green. I taking this very small crop, staying away from the border and closing them, all right? Then what I can do, these are three different vegetation features. Maybe now I can just go to other things. For example, I can go to urban areas here in Torino. Let me check if I can go in some places. For example, you see here I have these very huge black areas. These are industrial areas. New ROIs, let's write it here, urban in general terms. Urban could be red. So I'm taking a polygon in the red color out of this green, very dark area. I'm completing that. And then what I can do more, I can switch and go into the river, for example, here. All right. So new ROI, water, okay, blue, but now I'm not using the polygon, but I'm using again here for the first time the polyline. How is working the polyline? That you are just drawing a polyline in the middle of the river. You see here, and when you release the button, click the the right one and complete and accept the polygon. So whatever cell is touched by this line will be extracted. We are using polyline when, in this case, when we have these linear features to be extracted, where the polygons is not effective enough. And so we have this water. All right. So now we have the different, you see, um, ROIs, because we can pass to the different ROIs, urban, you see, corn, forest, and rice, all right? So what we can do right now, having this rice that was in white, all right? So we can just click on the compute statistics, all right? So what is that? This is, I mean, we were used when extracting these things from multispectral images to have a spectral signature. This is more or less the same things, but of course is not a spectral signature, but is what we can name as a temporal signature. So in this case, the variation in 5 different times, where 1 is April, 2 is June, 3 is July, 4 is August, and 5 is September, we have the variation, y-axis,
of the NDVI. You see, the NDVI in this case, rice, is always positive. So that means that is vegetation. And you see, this is representing, of course, with the 5 different lines, because as the spectral signature, here we have in the black lines the mean value, in green lines the standard deviation, and in the red lines we have maximum and minimum. So I mean, this is something that is very similar to the phenological cycle of rice. Using the NDVI, you see, we are starting in April water. You see that there's still water here because in June there were bare soil, then they are flooding the crops. So I mean, the NDVI is lower, and then it's starting to increase in July, stable in August, and decreasing in September. This is the phenological cycle of rice in Europe. So I mean, this is how I mean, it's increasing and then decreasing the NDVI. And the NDVI, of course, stands for the vegetation vigor of the plants. If we are passing now to, for example, the spectral signature of corn, or the temporal signature of corn, we are selecting corn and then we are computing the statistics. Okay, this is the statistics of corn. You see that is different from this one. You see that we don't have a falling in the second day, that is June, but is increasing in a linear way from April, passing through June, then to July, very stable in August, and falling in August. You see, again, very positive value of the NDVI. So that means that, again, this is vegetation. And this is the phenological cycle of corn, for example. Let's see the last one, vegetation we have, the forest. Let's click on the compute statistics, and you see the statistics. This is forest. You see, we are passing from very high, you see, you could look at the scale of values, and this is forest that is characterized by very particular trees, because I mean, they are losing leaves in autumn. So they are not like coniferous trees that are always in a vegetative state, and in which we can see this line very parallel to the different acquisition time, because I mean, the photosynthesis is always active. Here you see that is active from June to September, but it's increasing from April to June. That means that I mean, here the leaves weren't there. So I mean, they are losing leaves. They are not coniferous, all right, trees. This is the third example of vegetation. Let's check how, for example, its water is behaving, all right? Compute statistics. And you see, look at the scale. This is for offshore, of course, is not vegetation. The NDVI is less than 1, so this is water for sure. And you see that should be stable, but it is not very stable. You see that it's changing from April, it's increasing the value in June and July, and then it's falling down again here. Why it's happening that? Because I mean, consider that the third one is July, this is August, and this is September. I mean, here in April and June, there's a bunch of water in the Po River. Then in July and August, there are less water. And when there are less water, what is remaining? It's remaining the vegetation alongside the water, and also some algae in July, because there are very small water. So that means that the NDVI is increasing, and you see here it's more or less like zero, because I mean there's very small water, so I mean there's not such as an absorption in the near infrared, and so that means that when we have more water, the NDVI is decreasing. So you see that here in April and September we have more water than in July, and so there's much absorption. Okay, so using, for example, the NDVI for water, you can understand and you can have some information, not really quantitative information, but for example, concerning the runoff of the water, how much water does in the river. The last one is the urban. Let's have the statistics for the urban, the temporal for the urban. You see that the values are comprising a very short ranges of values, and this is quite stable. It's not changing anything there. You see, it's very little changing. So I mean, it's more or less parallel to the to the x-axis. I mean, it's not changing anything. They are these two, these very two last temporal signature. They are characterized by very low variation. All right, they are grayish tones. In particular, they are, I mean, very very dark tones. While, for example, here for the forest, we have whitish tones that are characterized by having a very stable NDVI, but high NDVI, you see, is close to the top at 0.9, while here for the vegetation, for the urban, for example, we have something that is very close to zero value. That means that in the red and the infrared, the reflectance is more or less the same, right? So you see what many things we can do with multi-temporal analysis. So I mean, I consider that it's enough for today. If you want to just train yourself by your own, you can do these things here. We are not doing here because we don't have time. But if I'm opening the file, you see, and I'm going to the original position of the data, so if I'm going to the multi-temporal analysis, we use the data that we have here in 2015 folders. But you can train yourself by performing the same analysis here. So using this folder where you have 3 acquisitions, but these 3 acquisitions, this is a multi-temporal analysis, but it's based on the fact that we have data acquired in 3 different years, 2003, 2011, 2015, and pay attention, because in 2003 we have Landsat 5 data, so we have only 6 bands. In 2011, again, we have Landsat 5, so again, only 6 bands, while in 2015, of course, we have 8 bands, so pay attention to the NDVI. But if you are trained for yourself here, you will have in the same period, more or less, so that is July and August in the other 2 days, you will have the NDVI calculated, for example, for the rice and for the crops at the top of the season in the maximum vigor of the vegetation. And so comparing in a temporal signature, doing the same things, but not for 5 days, but only for 3, you will have not the phenological cycle, but the vigor calculated in 3 different years in more or less in the same month, in July and August. And so starting from that, this is the period in which you have the maximum vegetation vigor. So this is a data that is, from the NDVI point of view, related to the possible production. So if you are going, for example, to rice and corn, and you are extracting this temporal signature for these 3 days, if you are observing something that is fluctuating, that means that in that particular year, the vigor of the vegetation was higher than the other 2 days of acquisition. So that possibly and eventually this year was more productive than the other 2. Or if we have the same situation in 2 years and are falling in another year, that means that the 3rd year was less productive than the other 2. All right? So this is this analysis that we are not doing, but you can do for yourself, is related to the possible calculation in different years of the productivity of particular things. All right? So if you're interested, you can go on with these labs by your own. All right, I think that for today it's enough. So thank you for your attention. We will meet for the very last labs next time. And of course, take care. And in this particular tough period, never give up. Bye bye.